Astronauts to the moon.
Ignition sequence start. 3, 2, 1.
Houston, we have a problem.
Liftoff. We have a liftoff.
We copy you on the ground. You got a bunch of guys about to turn blue.
What you're seeing here is a mirage. Are you ready?
Debate fans,
Are you ready?
for the handful in attendance and the thousands watching across the world, brought to you tonight by Jeranism, the #1 YouTube channel in all of existence. Ladies and gentlemen,
Let's get ready to rumble!
Make sure your argument is tight. Babe, what? You must got proof if you so right. Babe, what? Don't get dismissed on false claims, cause you gotta bring the truths and the facts. It don't matter if you're talking about racism, sexism, scientism, paganism, socialism, communism. Talk about capitalism, atheism, globalism. What about creationism? It don't matter what the ism. Live on debateism.
Welcome one, welcome all. It is time for another debate. We are on to episode number 26 on the Debatism format. Thank you guys for joining us. We have an exciting one tonight. We've got Roohif versus, do I have to introduce you as the king of geometry? Roohif, the king of geometry, versus Kyle Adams. We'll let you pick whatever you want to be king of too, since Roohif gets to. We're talking about the shape of the Earth. Is it a sphere? Is it flat? We are going to see what these two gentlemen think. Let's bring them on. First, we've got Roohif over here on the left. Roohif, say hello to everybody. They want to say hello to
Hello, everybody.
That's nice of you.
The king of geometry will do just fine.
All right, we got that. We'll get you a crown. It'll be like a globe crown or something. Be cool. All right, and we've got Kyle Adams in the house. Kyle, what's up?
Hello, good to be here. Yeah,
Nice to have
always
you.
a pleasure.
Okay, so
I guess this is my first time being over here, though. So.
yes, welcome.
Yeah, yay.
Are we doing a coin toss or for who's going first, or what do you guys want to do? We'll do coin toss. That's probably easiest.
Sure.
Let me.
Carl can go first. Carl can choose.
All right, that's nice of you. Very nice of you to defer to the newbie. Kyle, what do you want to do? You want to go first or second? Let's pretend you won the coin toss. It's heads. You picked heads. Go ahead.
I'll go ahead and go first. I'll get that out of the way.
Okay, so we got 3-minute intros, and then we got some claims and questions to ask and to answer. You got 3 minutes. When you start, I will start the clock.
Okay, so I'm Kyle Adams. I'm on the Globebusters show, Globebusters Tech, on Thursdays. It's always really fun. And I really enjoy debates. My main focus in doing a debate is conflict resolution. If you're going through a debate and no one changes their mind, then there's no point. The entire point of a debate is to change someone's mind. And so all of my questions are really focused on changing minds. My YouTube channel is Kyle Adams Abolish NASA. That's the easiest way to find me. I'm also on Facebook, Brighteon, and a bunch of other places. So you can look around for me. That's my intro.
Okay. Roohif, you want to go ahead when you start? I'll start the clock.
Yeah, I'll just share screen. Share, don't need audio. Oh, excuse me as well. So yeah, I'm Roohif, obviously. I didn't know much about Kyle until the other day. We'd chatted briefly on his channel and on his Miro board occasionally. But I watched a video he put out yesterday about Earth bulge. So how the Earth, due to its rotation, sort of bulges out at the equator. So it's an ellipsoid rather than a perfect sphere. And this quote that's on the screen just now came up. It says, "This conclusion directly contradicts the explanation which presupposes that the Earth moves," by Albert Michelson of Michelson-Morley fame. And that is from a journal in 1881. Excuse me, been sick all week. And if you read that quote, you would think that Albert Michelson has concluded that the Earth doesn't move. But if you read the paper, there's quite a few paragraphs in there that obviously say that the Earth, or he believes at least that the Earth is moving. So, to coincide with the direction of Earth's motion, considering only the velocity of the Earth in its orbit, direction of the Earth's motion in its orbit, and again the Earth's motion in its orbit. So these are all from the same source as that modified quote. You'll notice that there was a little ellipsis in the middle, but the paper itself, clearly shows that he doesn't believe that he, disproved Earth motion. So that's a misrepresentation of what Michelson actually thought. All right, so the actual quote is that his hypothesis was that the Earth moves through a stationary ether, and that's what he was testing. So you'll see the second paragraph there. So you've got the parts that are in the original quote mind quote. This conclusion directly contradicts the explanation of the phenomenon of aberration, which has hitherto been generally accepted and which presupposes that the Earth moves through the stationary ether. All right, so the quote mine was shortened to misrepresent Michelson's view of the Earth's orbit. So I want to give Kyle a chance to either retract the quote mine or double down, and then the audience can make up their mind on that, on his integrity. That's the end of my intro.
Okay.
Thank you.
I feel like that's kind of like a opening claim there that you're kind of looking for a rebuttal on. But I'll just say that it's a great topic. I've got the entire article, and that right alone would be a great video to get into, where we actually have the time to really open up into it.
Okay.
Okay, so I'll have Kyle start. Kyle, you're going to start with one of your questions.
Okay, I'll ask my
Let me bring up your questions. I'm not
one opening
prepared.
question. Share screen.
And you're sharing?
There we go.
Okay. All right. Do you agree that the globe Earth significantly breaking the orbital plane should break the heliocentric model, making it so none of the planets appear where they're supposed to? So if the Earth was way up here, kind of in this comet's trajectory, do you agree that that would totally mess up where you see the different planets over here?
Right. So you're asking a hypothetical, and like I know why you're asking it, because your further questions try to show that you think the Earth is breaking the orbital plane. Right. But my response to the question as it is asked at the moment is that if the Earth's orbital plane was way different to the other planets, then that would be the heliocentric model, right? The heliocentric model reflects reality in that our Earth's orbital plane is roughly the same as all the other planets, except for Mercury, I guess. So I'm answering your hypothetical with the answer of the Earth does not break the orbital plane.
So you disagree?
Well, if the Earth was at a different incline to the rest of the planets, that would be the heliocentric model, right? Do you get what I'm saying? Our model is that it's in line.
Our heliocentric model currently as it is.
Yeah. Yes. They're all roughly on the same plane. Yes.
Yeah. Our current heliocentric model has the Earth on this orbital plane. But if the Earth was not on the orbital plane, do you agree that that would break our current heliocentric model?
Sure. Yes.
Okay. So you do agree?
Yes.
Okay.
Yeah.
Cool.
But it's not. So the Earth is on roughly the same plane as the others.
Okay. We'll get into that.
Okay, Roohif, if you got a question, go ahead.
My question. All right. So Kyle is of the opinion that science proves things. So you have a phenomenon in reality, and you come up with some explanation. All right. So I might say that the sun sets. My proposed explanation is that the Earth is rotating. I have to drink all the way through this, I think. My proposed explanation for why the sun set is that the Earth is rotating, right? So then that's my hypothesis. I go and make some predictions, some other predictions based off that hypothesis, and then go and test them in reality. If the test in reality matches what I expect, it's a logical fallacy to then say that that hypothesis has been proven scientifically. That's a fallacy. It's called affirming the consequent. If my model predicts something in reality and reality disagrees, then my model has been falsified. All right. So the question for you is, and this is one question that I think Jeran would appreciate, because Jeran likes discussion questions rather than gotcha questions. Is that correct, Jeran? So this is like a free-form answer for Kyle to explain how he tests an idea against reality in order to prove something. So it's a free-form discussion question. Go for it.
Okay. Am I good to answer now?
Yep. Go ahead.
Okay. When it comes to proving things, the example that I often turn to is a burnt pancake. Okay, I can prove that pancake is burnt because it looks burnt, it smells burnt, it tastes burnt. It kind of crunches when you scrape it or things like that. Okay, there are no predictions required to prove that a pancake is burnt. It just has to match all of the definition of being burnt. Similarly, I don't have to predict anything to prove that I have 5 fingers on my right hand. I can show it to you. If we were to meet in person, I can let you touch my hand and experience it, examining it for yourself. Again, no predictions required for proving that I have a right hand.
Cool. Okay. So the burnt pancake and 5 fingers are just observable facts, right? Science does observations and observable facts and that sort of thing. But the idea of science is to come up with an explanation, right? And to go from a fact, such as a burnt pancake or 5 fingers, to some sort of explanation. So you might say, the reason we have 5 fingers is something to do with evolution, whatever, it doesn't matter, right? But you go from a fact in reality, and then you have to make what's called an inductive leap or an inductive inference to what could be an explanation. Why is it that we have 5 fingers? 5 fingers is a fact, but why? Right? And as soon as you make that leap to an explanation or a proposed explanation, I personally cannot see a way to then go, here's my hypothesis, and here's an experiment that proves my hypothesis. I can't see how that's logically possible without affirming the consequent, like I said a minute ago. So you've presented facts rather than explanations.
Science is a collection of facts.
I think we disagree on what a fact is then.
Okay.
And what science is. Yeah.
You're welcome to,
Yeah.
I've just seen you no true Scotsman, the whole science appeal there, but I don't think this is supposed to be debate and claim right here.
True.
That's my answer to your question.
Okay. I think science is a way of providing and testing explanations. That's what I call it. And we can differ on that. That's fine.
Okay.
Cool.
Kyle, go ahead. You got your next question.
Okay. My questions are going to come after my claims.
Do you want to do claim one then?
The further claims. And so
okay, we're doing claim.
Ready for me to get into the claims? We can do that.
Sure.
Unless you wanted to go first, but either way. But
go ahead.
Okay. Let's see. Okay. So I'm gonna go ahead and share screen again.
Okay.
Okay. The heliocentric model can't work without breaking the orbital plane. So I'm just going to build the globe model for you here. On the globe model, the sun should be parallel with the equator on the equinox. Okay, so we get this parallel line with the equator. Okay, and please notice how on this curve, okay, directly overhead is going to be in a different direction over here and over here than it is over here. Okay, that's kind of how that works. Okay, now adding to this model, Polaris should be perpendicular to the equator. Okay, and we should have 2 equinoxes every year. So right here, we've already kind of established an orbital plane. Okay, this is the analemma. I learned about that after I got into flat Earth, and was like, oh wow, that's major evidence that the speed of the sun changes throughout the year. Okay, when you put that together, you have to break the orbital plane in order to make the solstices work on the equinoxes. So you're trying to, or I get, we've got the orbital plane over here, and sorry, I've got the solstices appearing over here. And in order to do that, you have to move this one up and or down on that orbital plane in order to maintain the perpendicular status with Polaris and the equator. So do you agree that the Earth would have to move north or south in order for the solstices to take place? That's my next question.
Your claim and question. No, I don't. And I did point out to you a couple of days ago what the issue is with your first diagram. So I'll share screen. One sec.
Okay.
Oh, zoom. There we go. Oops. Share orbit. All right. So I did this in GeoGebra the other day. And it's a 3D model of just the Earth and the Sun. So obviously the Sun's at the center, and the blue thing's the Earth. And all I can do is make this rotate around the Earth. All right. So your first image, first slide said that at the equinox, which is here, that the equator is parallel with the orbital plane. It's not. So at equinox, that's what it looks like. Oops, there we go. Does that look better? So the orbital plane is dipped down into the screen. It is not parallel. All right. So Polaris is above the poles, but if you look at that from the side, Polaris is way off over there in that direction where that purple line's pointing. It's not directly above the orbital plane of the solar system. So you've got a fundamental misunderstanding of the heliocentric model in that first slide, and that affects the rest of your presentation.
This would be the equatorial plane.
Yeah,
so that's breaking the equatorial plane, but that's different from the orbital plane according to your model here.
Yes. So the ecliptic plane, or the plane of all the orbits, is that big plane. The black line, that's the equatorial plane. It is not parallel to the ecliptic. So I just disagree with your first premise.
Okay.
Cool.
Okay. Guess you're going to go with the claim?
My claim, what's my first claim? Fuck, hold on. Where is it? My first claim is plain sailing. Plain sailing often gets brought up in chats in Discord or whatever as they treat the Earth as a flat plane to sail over relatively short distances. Let me bring up my slides. How do I change the?
You might have to stop sharing.
No, I can do it. It's all right.
All right.
Oh, is that better?
Don't ask me next time. Yes, go ahead.
Figure it out in my head. Am I shared?
Yep. Good.
Cool. All right. So plain sailing treats the Earth as flat. And here's a little excerpt from just some website, Seafarer Education. So plain sailing is so called because we pretend the Earth is flat for the purpose of the calculation. Because of this, plain sailing is only accurate enough for distances under 500 nautical miles. So yes, plain sailing does treat the Earth as a flat rectangular grid. So all the latitude and longitude lines are orthogonal, perpendicular to each other. And because they're perpendicular to each other, if you want to go from one lat long to another lat long, you do it by drawing a right angle triangle. So on the right here, we're going from 58 south, 150 east to 62 degrees south, 160 degrees east. So we're going south by 4 degrees of latitude and going east by 10 degrees of longitude. All right. So now we're going to make a triangle and try and get some sides. The southward distance. So this edge, you just go 60 nautical miles per degree of latitude. That's a rule. Like if you back away from Polaris 60 nautical miles, it will drop 1 degree in the sky. So it's every degree of latitude is 60 nautical miles. So we know this edge of the triangle, it's 240 nautical miles. All right, but how do we work out this distance of 10 degrees longitude from 150 to 160 east? All right, and that east-west distance is called the departure, and it's calculated by getting the difference in longitude, which was 10 degrees, and the key is that you multiply it by the cosine of the average latitude, right, and then convert it to nautical miles. And this formula, the fact that you multiply it by the cosine of the latitude actually tells you the shape of the Earth, right? And I said, but Roofy, I don't know any trigonometry. Please explain. Right, so if I'm at the equator and I take the cosine of 0 degrees latitude, that equals 1. And we multiply that by 60 nautical miles per degree, and we get 60, right? So every degree of longitude at the equator is 60 nautical miles, that wide, all right? If our middle latitude or mean latitude is 60 degrees south, which is our 58 and 62, the cosine of 60 is 0.5, right? And that means there's only 30 degrees or 30 nautical miles per degree of longitude. And then I've got another example. If you're close to the poles at 85 degrees south, then the cosine of 85 is 0.087 multiplied by 60, and you get about 5 nautical miles per degree of longitude, right? And that tells you that lines of longitude converge at the poles. So they don't radiate out like the AE map. Welcome to the globe. So this is like a visual representation of what the plane sailing method tells you about the Earth. So at the equator, the distance between these longitude lines is 60 nautical miles per degree. As you get closer to the poles in both the north and the south, northern and southern hemispheres, that distance shrinks. The longitude lines converge. There's my claim.
Okay. Kyle, you want to go ahead and answer that? Go ahead.
Okay, we're jumping to claim 1.
Yes.
Give me a second here while I pull my... I was all ready to answer his question, but didn't see it. Sorry. Okay, my rebuttal. We don't live on Mercator map. I don't claim that's what the flat Earth looks like. So on the flat Earth, we have the North Pole at the center, so the lines of longitude are going to converge on the flat Earth map as well.
Not in the south.
But not in the south, yes.
Right.
They're going to diverge in the south. And so, yeah, that's it. If you want to try and like argue against the flat Earth, you got to know what you're arguing against. You can't just say, "Oh, well, it doesn't converge on the Mercator map, so therefore you're wrong." You're like, okay, as long as I don't believe we live on the Mercator map, that's not really an issue.
Do you believe plane sailing works in the southern or the outer ring?
That plane sailing works in the outer ring.
Yeah, the southern hemisphere. Yeah.
So you didn't really describe exactly what plane sailing was
Didn't I?
sufficiently, at least for me to fully grasp and understand it. You just called it plane sailing, and so I'm not really sure is my answer.
Okay. Well, can I say that I gave you these claims and questions 4 days ago, I think?
Yeah, and if you want to be vague then you're still vague now. So
I can read off the claim. I did read off the claim, didn't I? I would have thought that would be your prerogative to go and research what plane sailing is to have a rebuttal.
Yeah, that's kind of on you to do your explanation for the audience here. And if you want to change my mind, then that's kind of on you to present it properly.
Okay, I went through the geometry of plane sailing. I think the audience saw that. So if you don't have a rebuttal, it's fine.
Okay, yeah, I've got further when it comes to this whole thing here. So yeah, I was just gonna say that when it comes to if longitude was a problem, they wouldn't use the Gleason map in navigation systems, and I've got a patent that uses a Gleason map in the navigation system. And if you want to see that, I can open it up for you.
Right, but if you claim the Gleason map can be used for navigation, I will bet my left testicle, right, that it doesn't get used. I will guarantee you that under the hood, Havasine or Vincenti is used to work out distances and bearings.
Distances and bearings?
Yeah, if you want to navigate from point A to point B, how do you know how far it is? What direction do you travel? The Mercator map can be used reasonably good for that, yeah.
Well, it's different on land than it is in water, because on land, you can actually know how far it is by using an odometer on your car, but you can't really do that out in the ocean. You can't.
Sorry, you're saying you can't know where you are in the ocean, or what are you saying?
You can't. Odometers for cars don't work in the oceans unless you're dragging along the bottom surface of the ocean, but no one really does that unless you're talking about like the deep sea cables, and they're kind of measuring those out, and that's kind of a different story. But when we're talking about like the surface area across the ocean, you don't just drag an odometer there and say, oh, this is how far it was.
Right, but you can see your speed relative to the water.
If you know how fast the water's going.
Yeah. Oh, yeah. Sorry, ignoring currents, right? But you can see your speed relative to the water.
You can see your speed relative to the water. If you have other objects in the distance to kind of go off of, like if you're looking at a mountain over there, you can kind of watch the degrees and shift of that mountain over there.
You're saying you're in the middle of a lake, nothing, or middle of the ocean, nothing around you. You're moving. You're saying you can't see how fast you're going relative to the water?
Okay, you can drag what the navigators used to do a long time ago was keep a chip log, and that tells you kind of how fast you appear to be moving. Okay, but if that water is moving, you can't tell the difference between whether you're moving or whether that water is moving. If you're running on a treadmill, for example, you can be going, kicking your feet really, really fast, but essentially you're not running anywhere.
But I said relative to the water.
It can happen in the air, and it can also happen in the water. And so you could be spending a long time, oh, my engines are chugging really hard, but you have no idea if you're even moving at all, unless you can have some reference point to tell you. And so what a lot of old time navigators...
The reference point, when I say relative to the water, I mean the reference point is the water. We're ignoring currents, right? So relative to the water, can you see how fast you're going?
Like I said, that's what a chip log does. But just because you've got high RPMs, that doesn't mean you're moving. Like you could be moving, or the water could be moving, and that's the hard thing to distinguish.
Your analogy, right? Your treadmill analogy is saying the currents are really strong, right? I'm saying relative to the water, can you see how fast you're going?
Okay, if the currents are really strong, you don't know if you're moving or if the water is moving.
Jeez, answer the question.
That is my answer to your question.
Okay, relative to the water, can you work out how fast you're going relative to the water? Ignoring currents, we'll deal with currents in a minute.
Okay, so that's what a chip log does, is it measures kind of the water's moving this way and I'm not keeping up with the water. Okay?
That's what a chip log does. You're moving relative to the water.
That
currents,
tells you
the
kind of
currents
how fast you're moving. The water could be moving, or I could be moving, but exactly which one is like geographically moving, you can't tell.
Right. Okay. But I agree with that. But relative to the water, can you work out how fast you're going relative to the water?
That's what the chip log does.
Okay. So yes. Okay. So if we do one trip from Western USA over to Japan or whatever, and the trip backwards, we can work out what the approximate current is.
You can work out what the approximate current is from going from.
If you do both ways.
And to, what was that place?
Just whatever, some long journey that you take roughly the same path on, but in both directions.
Okay, so what's your proposal for measuring how fast the current is going? Just drop a bottle
you do it
in
in
the
both
water
directions, right?
Just
You do
drop
it
a
in
bottle
both
in the water
directions.
and just not touch it?
You do it in both directions. You get different times, but you know your speed relative to the water. You can then work out distances and roughly what the current is.
Okay, so we send two boats at the same time going in opposite directions on the same path?
It doesn't have to be the same time, right? We'll just assume the current's the same constant.
Currents aren't always the same speed.
Okay, but then you're running into, just because I'm going that way, the current's really strong against me, and then when I come back this way, it's behind me. Like, just assume that they're the same current, right? Or you can do it at the same time, whatever. But if you do the back and forth journey and you know your speed relative to the water, you can work out what the current is.
Okay, so you're kind of losing me here when it comes to your overall claim and point.
What was the claim? The claim was plain sailing, right?
Mm-hmm.
Yeah. We're a bit off topic. Plain sailing, right? The method of plain sailing tells you the shape of the Earth because it tells you that the geometry of it tells you that lines of longitude converge to the poles. That's the claim. There you go.
Okay, and I already responded to that. So,
well, does plain sailing work in the Southern Hemisphere?
We can get more into the problems that I don't think you're taking into account in your next claims.
All right, whatever.
Okay, go
Next
ahead,
one.
Kyle.
Okay. Let's see. Okay, and I will go ahead and share screen.
Okay.
Am I still sharing? One sec. Oops.
Yeah, I think
Stop
you are.
sharing. There you go.
Okay. Okay. So here we've got this diagram. The heliocentric teachers show you pictures like this over and over again. It's always with the equinox being on this far side. But if you bring that equinox over here, okay, they don't show it they don't teach it in textbooks from this position because it just doesn't work. And so anytime you bring this over here, you've got to significantly drop that equator line. And over here, and so all of a sudden now you're getting the solstices every time you move this over here and you're not quite lining up in the center. So do you agree that if the sun appears perfectly east and west on the equinoxes, despite being below or above the orbital plane, then the sun should appear perfectly east and west on the solstices as well?
All right. So there's an implicit claim in that question, despite being below or above the orbital plane. It's not. Back to your first claim, your diagram is fundamentally wrong. So scroll up just a little teeny bit. All right. So your diagram on the right, that's not the equinox. That's the solstice.
Uh-huh.
All right. And first of all, there's a slight error in that the black diagram on the right, you've got the sun pointing at the equator, not the tropics.
Yeah, I understand that this is not the equinox because that's my demonstration of if I try to move this globe over into this position, that's what happens. The equinox doesn't work from that position. And so I'll point out that with the equinox, okay, up here, you're above the orbital plane. See this little yellow line? That's the orbital plane on this model. And so
the Earth is not above the orbital plane.
And in the evening, you're on the opposite side of the orbital plane.
All right. So on the left diagram, that's the equinox. That's the the autumnal equinox for you guys.
Yep.
All right. The sun is the Earth is not above the orbital plane. That yellow line
part
will
of it
go
is,
through.
The other part isn't.
Right. So it goes through the center.
Okay. So the center is right here, and so
so it's not above or below.
Yeah. So here the sun is perfectly west of the orbital plane, while over here, the sun is perfectly east of the orbital plane.
Yep.
Sorry, not of the orbital plane. Sorry, it's perfectly east. That's kind of, you watch the sun rise perfectly east in the morning, and then despite being above the orbital plane, now you're watching the sun set perfectly east in the west, even though you're above on a completely different side of the orbital plane.
Right. By how much?
By how much?
Yeah. If you're at the tropics, right? If you're at the
Miles
tropics
away
on
the
the
orbital plane is from the from
the equator, right? If you're at the tropics, right, and you are 23 and a half, so that's 1,200 and something, 1,300 nautical miles above the perfect orbital plane. Do you realize how insignificant that is to 93 million miles?
Okay, I'm kind of wondering. You're just trying to minimize the issue.
Yeah, it's effectively zero. Yeah.
Okay, you're just trying to minimalize it, but that doesn't make it go away.
Because it's minimal. Should we do the tan of 1,200 nautical miles over 93 million miles? Okay, I don't think that would be measurable with any equipment that I have.
The issue here is about the sun rising perfectly east and setting perfectly west, even though you're so far away from. There's a big difference between the orbital plane there, and
it's not a big difference. It's 1,200 nautical miles ish from the tropics.
So, do you agree that if the sun appears perfectly east and west on the equinoxes, okay, despite being above or below the orbital plane, okay, above
by 1,200 miles,
okay, despite being above or below the orbital plane, then the sun should appear to be perfectly east and west on the solstices as well. So as you claimed, this is the solstice. And so, if this is a solstice, then the sun should rise perfectly east and west on the solstice.
No.
Okay, so you don't agree with that. Good to know.
I don't agree that the sun should rise perfectly east or west or anywhere near east or west. All right, I'm in Sydney. That's my east. That's my west. As the year moves on from the equinox a few months ago, my sunrise comes further around towards the south. I've probably got a slide somewhere that demonstrates that. Maybe we'll find it later. Did I point out the slight error in that black diagram? I think I did.
I just think it's interesting because it doesn't matter. No matter my elevation from or kind of distance away from the orbital plane. Okay, no matter the tilt of the Earth that I'm standing on, it doesn't matter what my tilt is to see the sun rise perfectly east on the equinox. Okay,
if the sun was maybe 50,000 miles away, right, then maybe you'd see a slight difference. I don't like the use of the word perfect either. Nothing's ever perfect. Perfect in meat space, as MC Toon likes to say. But the amount, if you drew a right angle triangle with the opposite side as 1,200 nautical miles and the adjacent as 150 million kilometers, I hate using fucking mixed units. That angle difference will be so tiny, several decimal places after the zero.
Okay.
Several zeros after decimal places.
So you're saying that for some reason it shouldn't be perfectly east and west over here because why? But it should be over here. Why is it different on the solstices than it is on the equinoxes? If
I'll try and find the
that's kind of the
meme. Hold on.
And if people have any questions they want to ask, you can send in super chats, Rockfin, YouTube, and
why would it be different on the solstices than on the equinoxes?
I'll show you.
Something I've observed is that at certain times of the year, even though I am above even though I am north of the tropics here in Utah, okay, my shadow will actually point south, like southwest.
Okay, can I share?
Certain times of the year.
Yeah, you're sharing.
No, Kylie's.
So here's my shadow, and you'll notice that it's pointing southwest. Okay, that's
your summer, right?
This is in summer, yeah.
Yeah.
And here I'm noticing the moon. Okay, I'm noticing the moon out here in the west, but the light, if that's coming from the reflected sunlight, as the globe model claims, okay, the light is appearing in the north.
Yeah, I think you're having trouble thinking in 3 dimensions. Can I share the share the
I'll
screen?
stop
Go ahead.
sharing and-
Cool.
And I saw some people in the chat
okay.
questioning the timer. They asked me to kind of let the time go as long as they were not talking over each other. So that's why we're not really saying.
So this is my sunrise in the summertime. So in about another month or so, this is what it will look like. So the bottom half of the Earth is pointed towards the sun. So it's my summer. And you'll see that in Sydney, my north is over here, right? My east is up here, but I'm seeing the sun rising way south of east. Right? This is the solstice, December solstice for us.
Okay.
Cool. So it should not set, it should not rise or set perfectly east or west at the solstices.
When you're doing this, how big is that sun supposed to appear? Like the angular size of the sun. Normally,
Same as it
when
always
I've
is.
seen it, it's really small, and now you've made it so it should be as big as the entire sky.
It's half a degree.
All of that is half a degree.
The angular size of the sun that I see is always half a degree.
Okay.
Or 0.53 or something, right?
And your
the sun
picture there
is
is showing the
physically
sun being like nearly the entire size of the
Right.
sky.
If I zoom all the way that way, if I zoom all the way that way, the sun will be bigger on the screen. It will be bigger. Right? It will be bigger than the Earth by a lot. That's different to what the angular size is. It's always half a degree, or thereabouts from Earth. Cool.
Okay. And on the equinox, it doesn't matter your tilt and where the sun appears, it's supposed to be perpendicular up above your head. Okay. And at noonday, but here that doesn't matter. What?
You said at noon it should be above your head. Where are you? What's
on
your
the
latitude?
Equinox, the longest day of the year. We get 2 of those a year. At noonday, it should be directly above your head. And
Not for you.
over here,
Where are you?
you're going to have directly above your head is going to be pointing in 2 different directions.
You're in Utah, right?
Yeah.
Yeah, your latitude's like 45. What is it? 40?
Not
Yeah,
Probably
40.
40.
You'll
Off
never
the
get
top
the
of my
sun. Yeah, you're never going to get the sun directly overhead. Neither am I.
Yeah. But if you're standing on the tropics, that's supposed to be what happens. And if you're on the equator, that should be what happens, even though they're at different angles from each other.
Yeah, on the tropics, you'll get the sun directly overhead on the solstices, and on the equinoxes, you get the sun directly overhead on the equator.
Even though they're completely facing in different directions.
I'm thinking that you have a lot of trouble visualizing things in 3D. Perhaps we should get you a simulator, like a stellarium or something. Well, probably a better question is it more likely that you're not thinking correctly about the 3-dimensional aspects of this thing, or you've found something that literally everyone else has missed? That's probably a good question, I think.
Things happen. And if you can show me that I'm wrong on this, then I'll happily change my mind. But unless you can do that, there's no conflict resolution.
Right. I would say get something like Stellarium, play with it, see how well it matches your reality, like your observations outside. I've found that it matches near perfectly, and it is a heliocentric globe model. It works.
Okay, so we have no conflict resolution here. You're just saying it doesn't work.
I can resolve
That's
it.
Hand wave dismissal. And
I can resolve it in that you're wrong and I'm right. That's the way to resolve it.
that doesn't resolve a conflict. So you've got to change my mind. I've got to change your mind.
Yeah, get
It's got to be
Stellarium.
one way or the other. Otherwise, there's no resolution.
Yeah, get Stellarium. Give it any observation, like your observation of the moon, right? Put that date and time in, get your location in there, and see where the sun is, where the moon is. Yeah, it works.
I should see the sun in the north.
Whatever date or wherever Stellarium says the sun should be, I guarantee you that's where it is.
And if that doesn't line up with what I showed
Yeah.
and
then
my
show that.
observation, is my observation wrong?
No. Show that. Show that. If you can show that your observation does not match stellarium, that would be great.
Okay, so
Yeah.
if stellarium shows that the sun should be in the east, okay, or in the west, and
Wherever
that's
it says,
what
yeah.
the globe says, right? It's always in the east or always in the west. The sun should never be 90 degrees above my head in the north. That's
It can
just a
never. It has
typical
never
globe
been
model.
above your head in Utah.
Huh?
It has never been above your head in Utah. You're at 40
Yeah.
degrees latitude. Yeah.
Yeah, that's fine. But my observation showed that the sun would be in the north.
Plug
If
it
that
in.
is the sun reflecting off the moon.
Yeah, plug it in to stellarium.
Okay, so I'll have to do that later. I guess that's my thing. I think we've talked about this. I don't think you've got anything else to put on the table here. And so, yeah, I think that was...
What do we have left? I don't know if we got it for everything, or I don't know.
I've only done one claim,
You've done
and I
one
think
claim,
Kyle's
okay.
finished his question and claims. So we can make this an interrogation session of me, if that's
Well, you can go
That's
with your
cool.
second claim if you want.
I've got
second
additional
claim.
questions and claims for you when you present yours.
Cool. All right.
I've actually
So
prepared a little bit more.
my claim number 2, I might share actually. Give me a sec.
We'll allow it.
All right. 1 second. Am I still sharing? No.
Not yet, no.
All right.
There you go.
All right. There we go. I was on Modern Day Debate last week with
Boo.
Brian Lee, Brian Leakey, and someone forget. Oh, Plain Reality. And I started off my presentation with Flurfs wouldn't know curvature if it bit them on the dick, and I stand by that. Flurfs will always say, "Show us the curvature," blah blah blah. It measures flat. So I've had this challenge open to Flurfs for I don't know 5-6 years, whatever. Set up a hypothetical. I'm on a flat Earth. An observer is at the top of a 5,000-foot mountain, pointing his theodolite to another 5,000-foot mountain that is 30 miles away. On a flat Earth and ignoring refraction for now, what is the predicted angle he will measure? Do you both, or do you agree, Kyle, that it's 0? You'd measure at 0 elevation.
Okay. That was your question? You're asking me your question now?
You can nod along. You can nod along if you want.
Okay. So
Yeah.
ask again.
So what if I'm at 5,000 feet on a flat Earth, looking across to another mountain at 5,000 feet, 30 miles away? The angle I should measure, if I ignore refraction, should be 0, right? Pretty simple.
If you ignore refraction and diffraction and the atmosphere itself, yeah.
Yes.
If there is no atmosphere on the Earth, sure.
Cool.
It should
Okay.
be 0. Yeah.
All right. So if we are on a globe, you've heard the 8 inches per mile squared of drop. Again, ignoring refraction for now, then that mountain should have dropped in our view by 600 feet. Like my 5,000 foot horizontal level should have dropped by 600 feet because it's 30 miles squared times 8 inches, 600 feet. So again, ignoring refraction, we should expect to measure an angle equal to that. Works out to 0.217 degrees down. All right. But we do have an atmosphere, as you so rightly point out, Kyle. And the empirically measured, I want to stress that, the empirically measured refractive gradient in the atmosphere it bends light downwards. So it's more dense below than it is higher up. And that curves the light downwards and lifts the apparent position of objects. And the amount of lift is around 1/7 that of the effective Earth curvature. That's why we use the 7/6R. So instead of 600 feet of drop, we should expect to measure around 500 feet of drop. So the angle, using basic trigonometry again, if we assume we're on a globe, we should expect to measure 0.186 down in this hypothetical. All right, I've done stacks of these measurements here and in California. And the key to getting good predictions is to do the measurements well above the surface where the gradient is quite stable and predictable. And the measurements that I took match the globe prediction and nowhere near the flat Earth prediction.
What flat Earth prediction?
Exactly. Do you guys have any predictions?
I do.
That was my second question, wasn't it? What was the predicted angle? Well, I can ask the question now because that's one of my.
Your statement
one of my questions.
assumes that kind of presented it doesn't match the flat Earth predictions, and then you have no flat Earth predictions you're going off of here.
Okay, so my question 2, which I probably should have done before this, was measuring drop. You're on top of a mountain which has an elevation of 5,000 feet. You're looking across to across a valley to another mountain 30 miles away, which also has an elevation of 5,000 feet. If the Earth is a globe and drops away at 8 inches per mile squared, what would you predict that angle to be? You can make any assumptions you need to make that prediction, as long as they are stated. Show your work.
Okay.
What's your angle?
You just barely provided your own prediction on that. Is that correct?
As in what my flat Earth prediction is?
No, your globe Earth prediction, because your question here is assuming a globe. And so you just barely provided your whole globe Earth prediction.
Right. So there's the globe Earth prediction, right? And you said I don't have a flat Earth prediction. Do you have a flat Earth prediction?
Okay. So you're kind of gotten a lot of questions going on, getting jumbled around. I kind of want to handle this systematically and make sure each of your questions gets addressed properly. So if you're ready for the question that you asked me, then I'm ready to answer it. Okay. Cool. Because I don't want to get all of this jumbled up.
It's the same question. make predictions for both flat Earth and globe.
Okay. So I can share screen because you wanted me to show my work.
Yep.
Okay.
You're good.
You're asking if the globe drops 8 inches per mile, how much does it drop? I'm going to say 8 inches per mile. Okay. We can go and do some additional math in here, which says it's approximately like a 0.22 degrees.
Sorry, did you ask ChatGPT for this?
I went through that because it's really good at making graphs and crunching numbers. It has This one is a calculator. It's DPI, and it actually works with math. And this one is actually from Rob Skiba's Testing the Globe, and he went and did the numbers on that. And yeah, it's kind of what you said there with the globe. Okay, the globe has about 600 feet of drop, and that kind of all seems to line up with the 0.22 degrees angle drop, if that's what you're asking. I'm not sure if you're asking angle drop or some other kind of drop.
No, angle drop, but also do you want to include refraction or not?
Okay. Well, you're just asking me how much drop does it have, and so I can only assume you were talking about geometrically. We're talking about, for you, you're talking about the geometric horizon, not the apparent horizon.
I'm talking about what angle will we measure in reality. So take into account whatever your reality is. Mine includes refraction.
Now we're kind of getting into one of your other questions, and I've gotten a separate response for that one when you're ready to ask that question. And I feel like you're kind of going all over the place here when it comes to your other questions now.
Sorry, what's the other question? This is just measuring drop. There's only one measuring drop question.
Okay, there's one measuring drop question. Yeah. And so you had question 3, and I've got your other questions here too, and your other claims.
Yeah. Question 3 is bottom-up obstruction. So,
which is kind of, I feel like the same kind of a question, but
not really.
I don't want to get things out of order, so it's all about systematization here.
Okay. Do you have a flat Earth prediction for what that angle should be?
Okay. You asked for a globe prediction. Okay.
Yep.
And so now you're asking a separate question.
Yeah.
So
it's on the fly. My apologies. It's on the fly. Absolutely. Yeah. I mean, you can say I don't have time to do it, and that's fine. I'm not gonna.
So let's just focus on what you got, and then we can address additional things after that, because I kind of got things all organized in my responses here.
Cool.
So
all right.
When it comes to how much of a drop you should see on a flat Earth, that's a part of a different question you asked that I've already kind of got a response prepared on that one.
Drop on a flat Earth?
How much apparent drop should you see on a flat Earth? That's a completely
You have an
question.
answer?
So I've got answers to that, but let's get to that first.
No, I give that. We're on measuring drop, right? So if you want to give a prediction for what the angle should be on a flat Earth, that'd be fantastic.
Okay. So I think that was part of your question 3. If you're asking
No.
question 3 now?
No, question 3 is bottom-up obstruction.
Yeah, which is part of it's part of that.
No, we're talking about measuring drop as in 8 inches per mile squared or not 8 inches per mile squared. Different. It's different to bottom-up obstruction. Yeah. So if you have an answer for what that angle should be on a flat Earth, I would love to hear it. If not today, then another day.
Okay.
We can wait till that question. If he's thinking that he has the answer for that coming up, then that's fine.
Oh yeah, I didn't explicitly ask for a flat Earth. Anyway,
Okay.
but I guess the point of that question is, if I go out into reality and my measurement matches my globe prediction, what would be your conclusion from that?
What would be my conclusion of that? Matching that. So I've got a big, long explanation here that kind of goes into one of your other claims here. So let's kind of get through that and then we'll come back. If you can write that question down, please do, because I think by the end of this, that should be answered.
Cool. All right. Do we want to go to my next claim, or what do you want to do, Jaron?
Yeah.
I'll go to my claim.
Okay, go ahead.
So the claim number 3 and question number 3 are about Canigou. All right. So in my humble opinion, long distance photographs are excellent globe evidence. For this, I'll be using a photo of Canigou from Logos Noof. I'll be showing that the vast majority of Canigou is blocked by the horizon, consistent with the Earth being a globe. And I'll also apply the laws of perspective and angular size to further support the amount of Canigou that is blocked by the horizon. Let me bring up that picture. Am I sharing? No, one sec.
Go ahead.
Hang on. Share. There we go. All right.
Good.
Cool. So I've got all the details of the observation. So it's that Alain guy in France. Here is the observer location and his elevation. Target's Canigou, 2785 meters, and it's 265.15 kilometers. There's a really cool website called Udeuschler, where you can get a 3D render of what it should look like under certain conditions. You can get it to make a prediction for what it should look like on a globe with standard refraction, and you've got the tippy tops, maybe the top 10% or so, 300 meters or so of the mountain range visible. You can ask it for a flat Earth prediction, and you can just see how big this mountain range is when you ask it for and get an idea of how much is hidden by the horizon. You've got the two predictions on the left on this slide, and then the actual photo. And the way you can tell, well, first of all, the mountains line up pretty well. There's a bit of an inferior mirage in that one, but you can see that it's a pretty good match. And we have the angular width of the sun to make sure that we're not sort of pretending that it's bigger than it is. So this width is 0.5 degree, and these little green ticks at the top, the green ticks at the top are 0.1 of a degree. So you can see that's about 0.5 degree across. It matches the globe prediction. And on the right-hand side, you can see there is an absolute shitload of the mountain blocked by the horizon, about 2,500 meters or so. What do I do here? Yeah, so there's the flat Earth prediction. You can see what should be visible on a flat Earth is all of that. And what is actually visible. And this is, I had Man of Stone tell me the other day that this is not the ocean. I don't know what to say to that, but I picked this particular photo because it has a boat in it. It's obviously the ocean. Yeah, so that's kind of good. I think that was my claim. Yep, that's kind of good.
Okay, so
Do you want me to ask the question, or do you want to respond to the claim?
okay, so your claim is, can you say that again in a non-convoluted way?
Long distance photos are excellent evidence for globe Earth. The predictions of a globe match reality quite well.
Okay, and you don't think long distance photos support the flat Earth?
No, you got 2.5 kilometers of a mountain blocked by water.
Okay, so you don't think the flat Earth acknowledges any kind of objects appearing to sink on the horizon?
If you, my question, I'll ask my question. All right. So you are standing on a hill. I'm basically giving you the coordinates. You are standing on a hill north of Aloche in France at 333 meters, looking at Canigou, 265 kilometers away. Assuming a flat Earth, how many meters or feet of Canigou do you predict is blocked by the horizon? And please show your work.
Okay, so now you're jumping over to your questions now. So first of all, I'm going to say my flat Earth model here acknowledges that objects can appear to sink on the horizon. And you appear to be saying that that doesn't happen.
How does it happen on a flat Earth? How do you get 2.5 kilometers missing?
Okay, my flat Earth model acknowledges that objects like the sun can appear to sink on the horizon. Okay,
show it.
I just want to get that through to you. Okay, and I wanted to know if you acknowledge that my model points out that objects like the sun can appear to sink on the horizon.
I acknowledge your assertion. Please show how it works.
Okay, so I got quite a bit into that. So I'm going to jump over to your question. This is question 2, right?
Question 3. So you're standing on a hill, bottom up obstruction. So do you want me to stop sharing?
Please.
Okay. So question 3. Okay.
Are you going to
share?
Do
you agree that the amount of atmospheric opacity affects how far the apparent horizon is?
Only on like foggy or really thick rubbish days.
Okay, so we can agree that the apparent horizon appears to rise and fall depending on what the atmosphere looks like. That's something that's common ground between us. Yes.
Not really. Once you get a decent height above the surface, the horizon hardly moves at all.
That's not been what I've seen at all.
I'll show you my measurements then. 1 sec.
Okay. So, with that being the case, I predict that the weather will be really foggy out on this day, and put
then don't go out.
Horizon 5 feet in front of the viewer. Okay, so
that's not a horizon, Kyle.
Will be covered by.
It's not a horizon.
That's my prediction. You asked me what my prediction was. Okay.
Having a foggy day.
How many meters or feet of Canada do you predict will be blocked by the horizon? Okay. Although I will say that the horizon, it is defined as the apparent boundary line between the Earth and sky. So, is that really the horizon that's blocking anything? Because the horizon, it can't really hide anything at all. Okay, it's just a line, the boundary line between the Earth and sky. It doesn't hide anything unless we're talking about diffraction and angular resolution. And we just had a great episode of Globebusters Tech where Zach went and described the angular resolution limits, how far we can see, and how diffraction can cause this bottom up kind of obstruction. It's kind of like two lights of a car. When they're close up, those two lights are kind of far apart, but the farther and farther away that gets, those lights end up merging together. And so that would be kind of the horizon line hiding things, depending on how you want to define horizon.
Is that water blocking the mountain?
Well, that's not the horizon blocking the mountain, and it's not water.
Is water? Are you saying that's not water? That's a fucking ship, Kyle. That thing there's a ship.
Don't be all upset with me, okay? I don't claim that's water that's blocking the horizon there. I don't believe
blocking the mountain.
That's not the water that's blocking the sun from your view, okay? That's not on my model, okay? That's not how my model explains things.
Okay. Is that water? That's water, right?
That's water.
Okay. Is it blocking this part of the mountain?
The water is not blocking that kind of part of the mountain. That's no
shit. Okay.
Okay, you're looking at the water there, but that's not the water that's blocking the mountain. Okay, there's atmospheric effects that can block things. Okay, that's kind of
that's water, Kyle. That's water. If the water wasn't there, would I see the rest of the mountain?
Okay, I've got in my model here the demonstrations that show you. Okay, So I've got multiple demonstrations that show you how objects can appear to sink on the horizon line out in the distance over flat surfaces. And so, Globebuster Zach over there, he's got his buckets out in the distance that appear to be merging with the ground, and they appear, to be getting hidden by the ground. But
how close to the ground is he? How close to the ground is that?
And I've demonstrated this with my fish tank laser experiment, where I took a boat and put it on one side of the tank, and then I shone a light through this salt water, and I got the light to bend downward. And as I did that, that boat appeared to be sinking on the other side of the tank. So
how close to the ground is Zach?
Huh?
How close to the ground is Zach? And how close to the ground are you in all these experiments?
Oh, I've got videos of that. I just showed you my camera always stayed above the ground.
How much?
The camera was on the ground. And I was also able to show how things appear differently when I kind of rise up in elevation.
Okay.
And we
For the fourth
explain
time,
how that's possible. How you're able to see
how high above the
elevations
ground
and
are you?
lower elevations. So that's something that's part of my model. And so, when you try to attack my model by explaining by strawmanning my model, it's not going to change my mind.
Okay. How high above the ground are all these demonstrations?
They're pretty low to the ground.
Okay. Don't do that. All right.
Don't do that. Why? Not think that refraction happens at high elevations?
When you get above the surface, like I mentioned previously, when you're above a decent height above the surface, the refractive gradient is really stable and predictable. When you're close to the surface, right, there's a lot of heat exchange going on with the air, and that can make refraction extreme in either direction. So you could get upwardly bending light, which will hide things in the vanishing zone, or you could get downwardly bending light, in which case you get things like the black swan.
Okay,
if you get
again,
above the surface,
my model isn't going to convince me that my model's wrong.
I'm telling you what the empirically measured density gradient is, Kyle.
That refracts the light that passes through it.
I'm telling you what the empirically measured density gradient is.
Okay.
I'm not strawmanning shit, right?
The density gradient of the atmosphere, but not the firmament.
What? Okay. If I'm looking 200 kilometers across to Canagoo, please explain how the firmament comes into that at all. That just sounds like you pulled it completely out of your ass.
I was jumping over to the sun. I'm sorry. How the sun appears to sink on the horizon. Okay, that firmament has to do with that stuff. Okay, but even on your model, the globe Earth model, have you ever seen the moon get refracted as seen from the ISS? Hopefully you agree that the ISS is higher than those mountains are.
Sure.
Okay, so you're saying there's next to no refraction from way up there.
No.
Therefore,
from the ISS, there's no refraction. From the ISS, there's no refraction.
Mountains, there should be next to no refraction up there.
No. Hang on. Let me get it before you misquote me. ISS is in vacuum, no refraction. When you're above the surface by a lot, refraction is stable and predictable. Didn't say it's no refraction.
Okay, I'm talking about the ISS and how you can see the moon get refracted from that elevation. Significantly refracted. So it's like squished.
Is it looking through the atmosphere?
Yes.
Okay, well, there you go.
Okay, so, there's still atmosphere up there. You're still looking through the atmosphere.
No. There's no atmosphere up here. I said, are you viewing the moon through the Earth's atmosphere?
Oh, I'm sorry. I guess NASA never told you that they now claim that.
Please don't say the atmosphere extends beyond the moon. Fuck me, Kyle. Have you read that paper?
That the Earth's atmosphere extends all the way out to the moon? I did read the paper.
Okay. What was the density of the atmosphere past the moon?
I don't recall.
Okay, 5/5 of fuck all, Kyle. All right.
Okay, so let's calm down.
Yeah, I'm calm. Do I look?
I don't know. You're swearing at me. That tells me that you're emotionally unstable here. So.
All right, I swear a bit. That's fine. Is anyone in the chat offended by me swearing?
Everybody. They all said that.
Okay. All right. You offended?
Yeah. No, not me.
Oh, ask Roohif if he's ever faked his own birth.
What?
Okay.
Again, just when it comes to my model, don't strawman it to try and fight my model. Okay, kind of
Okay, so where are we at on claims and I've lost touch.
The claim. Well, sorry, we're a bit off track. The claim was that the horizon moves around. As Jeran knows, actually, because I heckle Jeran all the time with
Constantly.
my observation of boats.
You disagree with that claim that the horizon moves around?
When you get above the surface by a decent amount, it doesn't. It hardly moves at all. All right. When you're close to the surface, like Skunk Bay or whatever, yeah, it moves around heaps. Don't bother with observations so close to the surface. You can get, if you get upwardly bending light, right, that can block. You get inferior mirages, and inferior mirages can block things bottom up. So what's the point of that observation?
Okay.
Or in the other direction, if it bends a lot downwards, you get things like the black swan. So
Okay,
don't
so-
bother close to the surface.
I've got a picture here I'd like to share real quick.
Well, hang on. Can we first acknowledge that April, May, June, July, August, October, horizon has hardly moved at all.
Okay, so like this picture ends up kind of going into what you're talking about here. That's very relevant.
Okay, stop sharing for a second there.
Cool. That's it. Boom.
Okay, when you're ready.
Okay, so you've got this picture. You can see all this cloud, and the
What are you doing?
horizon appears really near, like close to the observer. And we acknowledge that the amount of atmospheric opacity, the atmosphere's lack of transparency, can end up adjusting where that horizon appears to be, how much drop it is. And so in this case, the atmosphere being really thick is causing the horizon to appear really low. Okay, the atmosphere, the thickness of the atmosphere is causing it to drop. Now, if you're really at a high elevation, okay, you can still, when you look down, you can see the clouds. The clouds up here end up still being a factor. And sometimes you can get more clouds over here on your left than you do on your right. And so there ends up being kind of an apparent curve, but it's really just, I can see farther over here because the atmosphere is thinner over here than I do over here. And so that ends up kind of affecting the top of it. And so if I were to like flip this picture upside down where the water would end up being the sky, and you can kind of get this thing here. This horizon right here doesn't appear perfectly flat. Okay, that horizon right there appears to curve slightly. Okay, that is because of the atmosphere itself, it being thicker on one side than it is on the other nearby, and so that affects kind of the rise and drop of the atmosphere. Sorry, the rise and drop
got my response.
where the apparent horizon appears to be.
My response is that's not the horizon. It's a foggy day. Like, why would you go out? Why not go out in a snowstorm and try to measure the horizon?
Okay, so
Like, this is stupid.
by definition, okay, you're just kind of no true Scotsmaning the definition of horizon. Okay, the boundary line between the earth and sky. So this is the boundary line. This line right here, that's the boundary line. That is the apparent horizon right there.
I think that's a stupid definition.
Okay, that's a dictionary definition, and
okay.
no true Scotsman. That's a
All right,
stupid
so
definition.
Hang on.
Oh,
Can I read you the dictionary definition of Earth then? Let's read the dictionary definition of Earth.
Okay, what I'm going to call that irrelevant. Okay. There's
okay.
multiple
So
definitions of
your definitions are just better than mine. Is that correct?
If you're welcome to disagree with the definition, and you want to pull up the definition of Earth. Yeah, I'm welcome to disagree with the definition. That's totally okay.
Yeah. So it's not your dictionary definition doesn't just trump my definition of the horizon, right?
Okay. It's kind of okay. So if you want to define the Earth as a spinning globe out in outer space,
you want to define the horizon as a foggy bullshit
but
day.
That doesn't
sure.
mean when I use a definition of Earth, I always have to, because there's multiple definitions, and I can pick from a different definition of Earth when I'm referring to the word Earth.
Yes.
Okay? And so here you're talking about the horizon.
Am I allowed to do that with the horizon?
Yeah, just as long as you acknowledge or at least define what you're talking about. Because if you're using a different definition than the standard definition, then it's kind of on you, if you want everyone to understand you, to explain what you're meaning here.
Standard definition?
The standard definition, like the global.
Okay, the standard definition of Earth is that it has a polar and equatorial radius.
Yeah,
we can play this game, or we can just say we have different definitions.
I can acknowledge that we have different definitions. So,
Cool.
Okay, does anybody have any claims or questions left?
I think I've got another claim left. I think. Where are we?
Kyle, do you have any?
I've got my claims, and I've got some other things on here that are kind of in response to his.
Yeah, I don't see the point of making an observation when it's a foggy day. You cannot see the horizon. That's silly.
Okay,
All right,
well,
claim.
I gave you the definition. That was my response. So,
Okay. Earth is defined as a globe. So done. Claim number
Okay.
4, flight routes are excellent globe evidence. For this, I'll be showing that flights south of the equator tend to follow the Great Circle routes in both directions. And I'll contrast this by showing routes on the AE map. I did provide this to Kyle about 4 days ago, I think. And I said, if you have a different map that you'd like me to use, please provide it. He didn't, so we'll just go with the AE map. All right, let me share. All right, so the flight we're going to look at is Santiago to Sydney. And obviously on a globe, this route gets relatively close to Antarctica. So it flies basically southwest from Santiago, hits roughly 55 degrees south latitude, and then heads northwest into Sydney. The travel times and the calculated distances are consistent with the globe, and it cannot work on the AE map. All right, so I've grabbed the last three flights from Santiago to Sydney. They've been about 14 hours each. So it starts from Santiago, heads southwest. That's about 60 degrees south, and then up to the south of New Zealand and into Sydney. And then I've grabbed the green lines are the KML plotted paths that they actually flew, and the red line is the Great Circle route, so the theoretically shortest route on a globe. So that's what it looks like. Here is what it looks like with a wind map overlaid, and that's from the 12th of November, and they're pretty much similar on the 13th and the 10th. You can see that they're in a headwind. They're going into a headwind, so they're traveling from right to left. The wind is going left to right, and it gets there in 14 hours. The eastbound leg takes about 12 hours, 11 and a half, 12 hours. Because of the wind difference. Some people will dispute that it travels so close to Antarctica. I have a friend who was actually cabin crew on Qantas, and she flies this route quite a lot. And on the 17th of August, she posted some pictures of the pack ice north of Antarctica, a picture of the route that it's actually taking for that day, and a couple of videos and stuff. Pretty cool. So they do follow that route. The routes on Flight Radar 24 and what's the other one? FlightAware are the actual routes that they take, and they do go relatively close to Antarctica. So then I've mapped the shortest possible path on the AE map from Santiago to Sydney. That route would take them over, what's that, Colombia, Ecuador, something like that, over the continental United States. In fact, right over Utah. Is that Utah right there? Right over Utah, all the way, way north of Hawaii, and over Brisbane in Queensland, down southwest to Sydney. That's the shortest route on the AE map. They don't fly anywhere near that route. They fly this route. All right. And assuming there's 60 nautical miles per degree of latitude, I've done some calculations for these distances. This shortest route is 16,000 miles, and this actual route that they take is about 24,500 miles. No plane in existence has that range. So the question for Kyle is, how do you propose flying that 24,500 miles in just 14 hours? That's an average of 1,750 miles per hour into the wind. Or does a globe distance of 7,000 miles in 14 hours, so 504 miles per hour, make more sense? End of claim.
Okay. Do you agree that planes take advantage of jet streams in order to fly faster and more efficiently.
Yes.
Okay, so you showed the winds on the globe map, and I actually have the winds on flat Earth map. So I'll go ahead and share screen if I can.
Go ahead.
You do realize they're the same data, right?
Yeah, it's same data. Yeah.
Okay,
But
so
it just
so
makes a
how
lot
is it
more
gonna be
sense
Can you
when
different?
stop
look at it.
sharing, Roohif? So I think you.
Oh, sorry. Whoops.
Okay, it just makes a lot more sense when you look at it this way. So you've got these major jet streams kind of going all over the south.
Yeah. Which way are we flying?
Influential right there. So it's kind of like having a mountain in front of you. It might be the shortest distance to just climb up and over the mountain, but that doesn't mean it takes the same. Sometimes going straight up and over the mountain, traveling the shortest distance can take.
Can I interrupt just a little bit?
Than going around the mountain on the freeway.
Right.
So this is
there's
kind
a
of like
reason why I picked Santiago to Sydney and not Sydney to Santiago.
Okay, so I'm just letting you know that there are jet streams that affect how planes fly, the routes that they choose to take, and there are jet streams that go in both directions. So this one primarily shows you like one direction over the other, but they do go both ways depending on kind of your elevation.
No, they don't.
Huh?
No, they don't. I know the source data. This is NOAA source data, right? On the you're on earth.null school or Bob Wins, whatever, right? The data the source of the data is NOAA, all right? This website, Bob Wins, only shows you the 250 hectopascals, right? You can get all the data every 50 hectopascals. So 50, 100, 150, 250, 300 hectopascals.
You're saying it only shows 250, even though I can show you right here 1,700, 570, and 10?
Right. Planes don't fly at 500 hectopascals. That's like 15,000 feet or something.
Okay, so I'm kind of wondering, one, what makes you think that, and two, okay, there's a lot that comes down to here that kind of if planes can take advantage of the jet streams, that's going to directly influence where they choose to fly and
right.
How fast they end up flying. So it's kind of what I explained to you before about the chip log on water. You can be, getting a lot of RPMs, but you can be going either a lot faster than your RPMs are showing, or or you can go a lot slower than your RPMs are showing. But you don't measure speed using you don't measure miles per hour with your RPMs. You just don't.
Well, like I said a minute ago, there's a reason I picked Santiago to Sydney and not Sydney to Santiago. Okay, you're flying into the wind from Santiago to Sydney, yet on the AE map it was like 22,000 miles. So you would have to average 1,750 miles per hour into the wind.
Okay, so
Santiago is roughly where the where the really high winds are.
Okay, kind of.
There we go.
This. Okay.
Yeah, Santiago is where the pink, purple stuff is.
Sydney's over here. Santiago's down here. I can move this out of the way. Okay. And there are additional winds that kind of go the other direction depending on where you're at.
Again, do planes fly? Does that route go anywhere near 30 degrees north south latitude?
Okay. Do those go anywhere near?
Okay. Click on where you think the winds are. There will do, right? Do you think the winds will help you in that spot? Click on it. 31 degrees south, 6 degrees south. Are you going to see ice sheets outside the window at 6 degrees south?
Oh, you can go further south than that. Yeah.
Okay, so we're not in those winds. Go down to like 60 degrees south.
Okay. Going way down here.
Yep.
Oh.
Where the plane actually flies. Yep.
Yep.
Which direction are those winds going?
Well, these winds are going the opposite direction, yeah.
Right. How are you going 1,750 miles per hour into the wind? Okay.
How are you going Okay. I'm not saying that these exact same winds. They can, okay, planes can travel at different speeds, okay, depending
Can they
on
go
what the pilot
1750
chooses to
miles an
fly
hour?
at. Huh?
Can they go 1750 miles an hour?
They can.
Oh shit.
Okay.
Okay. Do you have
Do you not
any
believe that
evidence
about the ISS?
whatsoever for this?
Do you not believe that about the ISS? How fast do you think the ISS is
Talking
moving?
about commercial fucking planes, Kyle. Come on.
All right, let's.
So-
Do you have any more?
How fast do you claim the ISS is going exactly?
Oh,
So,
Kyle,
okay,
come on now. Come on, Chad.
Do we have any
so
more
it's going
claims? Or
pretty fast, according to you. Right?
It's not a commercial passenger jet, Kyle. I can't believe you said
Okay.
that.
Okay,
Alright.
so I'm just saying that planes can go pretty fast, and so
Can they go
these-
1750?
Huh?
Can they go
So-
1750 miles an hour?
that this is just at that one elevation, but there are other elevations that with counter winds that go the opposite direction.
No, they don't. I've got the data. You don't.
Huh?
I've got the data. You don't. In fact, I put out a half-hour long video about Southern flights. Come on, Jaron, you got to watch it.
I haven't watched it.
Showing the data at these different levels. I think it was 150 hectopascals, 200, 250, and 300. I think it doesn't change direction. It just doesn't.
You said there's somewhere we can go on NOAA that we can see by 50. You
Yeah,
said?
I can get you the link.
Yeah, just tell me. I would like to see that after. But let's see.
According to you, it doesn't change direction, and yeah.
Well,
and
what data
see,
are you using?
Part of my whole thing is that
Hang on. So you said according to me, you're showing the exact same data that I'm using.
okay. So this whole data right here is showing the winds going in one direction at one elevation. Okay, at one pressure. Okay,
Yep.
but this doesn't. This is kind of just one slice. Okay, and there's a lot of different elevations here, right? And I'm telling you that there are other elevations that planes fly. You're saying they don't. Okay, that's just a
No, I have the data. I have the data.
Planes don't
Kyle.
always fly at the same elevation.
Right, I
Do you
have
agree
the
with
data.
that or not?
Of course they
Do
don't.
you agree that planes do not always fly at the same elevation?
Of course they don't. Right.
Okay,
That's why I
so
got the
they use
150.
different winds. They use different winds for flying at different elevations.
Right.
And okay, I'm already under the impression that that NASA lies to us. The government lies to us, and a lot of this information comes from the government. And so, would it be too
But
surprising?
you're quite happy
Would it be-
using this data.
Well, yes. Okay, they acknowledge some things. Okay, and I agree with Neil Tyson left and right on so many things, but I don't agree with him about everything.
Same.
All right.
Okay, so you don't agree with him on about it? Great.
Oh,
So-
the Felix Baumgartner, yeah, wrong about that.
Okay, so you're it's cool that you're willing to take the courage to disagree with the mainstream on that. I applaud you on that.
I don't think it takes that much courage.
Do we have any more claims or comments from either one of you, or should we go to outros?
Yeah, outro's fine. Yeah.
3 minutes. I'm going to check if there's any super chats. I haven't seen any come through, but there might be. But who wants to go first? Oh, well, Kyle will go first.
Yeah, whatever.
Go ahead, Kyle, when you want. 3 minutes, and you can close us out.
Okay. There was a couple of other things that I wanted to bring up. Okay. Okay. So I've got the CNN report that says that planes can fly faster than the speed of sound. Yeah, but if you already acknowledge that, then there's no point in bringing it up.
Yeah,
So
not airspeed though.
okay, commercial planes can fly faster than the speed of sound by using
not
by
airspeed.
taking advantage
Not
of
airspeed.
jet streams. I told you to wait on. Okay. Do you acknowledge that my flat Earth model acknowledges that objects can appear to sink on the horizon? What was your response on that?
Show me the geometry. Show me how it works.
I said, do you acknowledge that my flat Earth model acknowledges that objects can appear to sink on the horizon?
No.
Okay,
Show how it works.
Okay.
How,
I've got a
if
lot
you-
of videos that get into that, explaining how it works. And
Anyway, it's your
my first
outro.
laser
so
experiment.
Yeah, let's go with that.
It's your outro.
But I guess we can get into that in a different debate. But right now, you do not acknowledge that my model says that objects can appear to sink on the horizon. Okay.
You claim it. I'm sure that you claim it.
Okay.
Show how it works.
And so I'm writing a no on that one. All right. And so you were asking another question here with predictions of a flat Earth. And okay, you're asking about, well, what if I am able to predict exactly what elevation that would be, or kind of the angle. If I were to show this, if I were to predict that I should see this much drop over this much distance, okay. You're asking about that.
So the drop over distance, what should your conclusion be if your prediction matches reality? And also, what should your conclusion be if your prediction doesn't match reality at all?
Okay, so the horizon appears to rise and fall depending on the weather. Okay, and so I should hope we agree with that. Okay, if you want to claim that you have the observation of proof, okay, that your observation of, oh, I got the right answer. Okay, if you want to claim that's proof, you have to show that what makes your instance more valid than all of the others, because horizon appears to rise and fall, right? And so it's kind of like you've got the right one. It's kind of like if you have a whole bunch of people in a room all claiming to be the same person, it's kind of on you to prove that those are the imposters and this is the real one. Okay, and so the horizon appears to rise and fall on the horizon. I've got videos of Skunk Bay, which is a really good example of that, where the horizon, you can watch it go up and down, and you can even watch the horizon cause things to hide things and then all of a sudden reveal things out in the distance. I don't know if you've heard of Skunk Bay. Have you heard of Skunk Bay before?
Well, it's at 10 feet. 10 feet or 10 meters? Yeah.
The Skunk Bay.
The Skunk Bay camera is close to the water. Get away from the surface. Stop doing things so close to the surface.
It doesn't look super close to the water.
I think it's either 10 meters or 10 feet. I looked it up one day.
I believe I have that time-lapse footage right here if you want to look at it.
I've seen it plenty of times.
Okay, so you've seen it plenty of times. It does not look close to the surface of the water. And you can watch the mountains in the background kind of rise and fall, right? So this is showing you that the horizon is not fixed, that the atmosphere can change where the horizon appears to be. And so if you want to say, oh, well, it matches my prediction now, and then all of a sudden 5 minutes later, it no longer matches that prediction, is that prediction still valid? Okay, is that proof that of anything? If you've got 5 other predictions that don't match 5 other observations that don't match your prediction. Okay, now you've got to be able to separate which one is true and which one is false. Does that make sense?
Yes. As I've said probably 5 times now, when you are close to the surface, like Skunk Bay, Black Swan, all these observations of lasers going over lakes.
Skunk Bay has no laser.
I know. But in addition to Skunk Bay, lasers going over lakes, mirror flashes, whatever. If you are close to the surface, the dynamics between the surface, be it water or land, and the atmosphere above it is quite unpredictable, turbulent, whatever you want to call it. And that affects the density gradient, right? To get a stable, predictable density gradient, refractive gradient, get well above the surface. There's a reason why my my questions were, you're at 5,000 feet looking across to another mountain at 5,000 feet.
Let's let Kyle finish, because you've said this 15 times already.
Yeah, no.
Okay. Just saying, we don't need to hear anymore. Kyle, do you have anything you want to finish with the outro? I'll give you time to finish your outro.
Yeah, sorry.
Uninterrupted.
So if you want to prove it, you've got to be able to take more into account than I have. And when in claiming that this is the true prediction, okay, this is the proof, then all the other ones that say, oh no, that's not proven. That make sense?
Cool.
Okay, I think that's it for me. I think I've said my piece.
Okay.
Feel free to interrupt my outro as well.
Okay, go ahead. We got 3 minutes for you.
Yeah, what can I say? I think the goal for me for this debate was to kind of explain how I go about not proving. I don't use the word prove as much as I sometimes use it, but I try not to use the word prove. The heuristic, or the sort of the method that I go through as to how I come to a conclusion. I have a model or an idea or a concept about what reality is. That model makes predictions if it's true, right? So I go and test them in reality. I've done that shitloads of times for both flat Earth and globe, and the globe's predictions match reality every time. Like Jaren gets the shits with me when I say I've never seen a observation that is inconsistent with the globe, but it's true. Like I showed before, those observations of the horizon at one of my boat locations. I can show you a couple more. I think I actually showed Jaren one observation where the horizon was like a teeny tiny bit higher than what it usually is, and I said that's quite a deviation from the globe prediction, but it's nowhere near a flat Earth prediction. Yes, that's all I want to say is that make predictions, go and test them, and you should have confidence in the model that answers correctly of the most questions or predictions you ask of it, and that's the globe. So yeah, the end.
Alrighty. Let me see. We do have a couple of super chats that came through. So let me ask these ones of you guys. Hold up 1 second. We will get you out of here quickly. I know you have something to do. Roohif. We've got Kyle Gray for $2. Thank you very much. Says, show one place that wind would cause a 1,750 mile per hour jet. That's for you, Kyle?
That comes down to, so it's like running on a conveyor belt. Okay. I alone can't run 100 miles an hour. Okay. But if I'm on a conveyor belt, then I can run a lot faster than I normally could. And so
we're going the other way.
A plane already can fly really fast. Okay. But a plane going through a jet stream can go even faster. And that's what allows it to go.
Right. We're going into the wind. Into the wind.
Into the wind. Yeah.
Yes. And so we're going slower.
Okay. However, okay, you need to remember that your data, okay, on miles per hour is based on the scrunched distance. Okay. You've got your whole globe is scrunched in the southern hemisphere. Okay. Compared to the flat Earth. And so on a flat Earth, okay, you're saying miles per hour, you're getting a lot more miles there that are not being taken under account. Does that make sense?
That makes it worse for you.
Okay, so those
if you're stretching,
those
if
winds,
you're saying
they're going from point A to point B, those winds are going a lot faster than the data says, because the data is going off of the miles on a globe, which is a tiny amount of miles. But
that makes it worse for you.
If it's going from point A to point B on the flat Earth, it's going to be going a lot faster than what the globe says.
Right, but if those are globe numbers and it's saying it's 100 mile an hour jet stream, but those distances are stretched, then it's like a 500. You're going into a headwind of 500 miles an hour. That makes it worse.
Okay, if you're going into a headwind, I'm talking about going with it.
I specifically chose Santiago to Sydney.
Yeah, and there are other winds that you can carry you in the
Please show evidence of that. I have evidence that they aren't. I have all the data, which I'll give to Jaren after this.
Okay.
They don't go the other direction between something like.
Okay. If you just look at one, if you look up the side, there are little things that go on there.
Okay, you're just pulling that out of your ass. You have zero evidence that that's true. Literally zero.
Feel free to take the course. We can pull out the magnifying glass and we can dive into that in more time.
Okay, Roohif, what's the actual formula, equation, etc., for working out the geometric curve of the Earth, and where can we find this from a credible source?
The geometric? So I assume that means no refraction. Yeah, just 8 inches per mile squared is fine.
Yeah, for as far as you can see. Okay, and Kyle Gray again says, show one place in all capitals. So he's get that data from Roohif and try and find through Roohif or through NOAA some sort of documentation that we have fast winds going the other way.
Yeah, I can give a link now to my code that pulls the data. 1 sec.
In the chat, you're going to do it?
In the Zoom chat. Now I've got to find it first.
I can't get to it right now. I'll also screw up the screen. But is that for after? Can we check Rockton real quick? And let's see here if we got anybody there. Coolio's over there in Rockton. What's up, Coolio?
If you give me mods, Jaren, I can post it in the YouTube chat.
Say something first and I'll moderate you.
Say something.
Say something funny. I see you.
All right.
Come back.
Am I modded?
Not yet. Where does it say? Oh, there it is. And you can just be a standard person. All right, there you go. Yeah, you should be able to post it.
Oh, did that show up? Yeah. All right. So that's my GitHub, where it has code that goes and pulls the data from NOAA and does a
For any flight or any time? Or
in the last 10 days.
Okay.
I'm trying to figure out how the Bob Wins guy goes back forever. Yeah, I haven't touched this for like 3 months.
Okay.
Yeah.
David asks, how come ball earthers are always so rude?
Come on now, champ, because it's not.
That's what it says. I'm sure
it's not a bad thing.
Oh, it could be.
If you are actually that good, right? Is it really arrogant? Is that arrogance?
Not in my book, but if it's misplaced,
Fantastic.
yes. Roohif, where should one find the geometric curve formula from a credible source?
Yeah. I mean, you can, like I said before, 8 inches per mile squared is fine. You can derive it trigonometrically as well.
I think the Metabunk site is pretty good because it lays out all the equations for each different version of, because there's like 4 lists, with refraction, without, with the geometric, the calculated, all these different things. All right, any other super chats? Doesn't look like it. We've got, can you tell everybody where they can find you, Kyle?
They can find me on Facebook, YouTube, Brighteon, Odyssey, and so on and so forth. And on Globebusters Tech on Thursdays.
Sweet. And Roohif, where can they find you if they...
Roohif on YouTube, usually in Discord, but my original Roohif account got nuked. Got nuked a few months back, or a year ago now. So it's Roohifnol with a Y instead of an I.
Okay. And do we get to find out where that name comes from? What is the reason for the name Roohif?
Many years ago, some friends and I went on a houseboat for a week and had some very unsavory ladies on board. Yeah, well, that'll do.
Well, now it's even worse than it was before.
It is actually like an acronym. Remember, you heard it here first. So RUHIHF, but saying it phonetically.
Okay.
Yeah.
Okay.
Anyway, that
sounds
fun.
better.
That was like 20-something years ago. Yeah.
Long time.
Yeah.
All right. We are good. Thank you guys for being here. Another fun debate. We will head out.
Hang
final
before
words.
We go.
Oh, what happened?
Shamrock Dan says you can find Roohif at the empty nudist beach in Sydney. My suburb actually has 2 of the most famous nudist beaches in Sydney. One of them's the gay nudist.
Don't
beach.
ever go. Whatever you do. I've been to one before, and it was the biggest mistake I ever made in my life.
Not exactly
Obelisk.
advertising for me.
Obelisk and Cobblers. Yeah, they're in my
Don't go.
in my suburb.
You're better off. Stay home.
Yeah.
Stay home. All right. Any final words for you guys?
No, thank you, Jaron. Thank you, Kyle.
Yep,
we'll do it again if you want to have another crack at the title.
And I believe I got an outro. All right. Thank you very much, guys. We'll see you. What is today? Saturday. I'm confused. Tomorrow is Globebusters, 12 noon Pacific on the Globebusters channel. So check that out. And then we'll see you guys next week. Wednesday, we got Reefer Roulette. I'm trying to think if there's something on Tuesday. We might have a debate. I'm trying to think. Anyway, I'll let you guys know. And subscribe at t.me/Jeranism show to get notified when we go live, when we have a new show. All right. Much love to you guys. Appreciate you being here for the debate. I remind you, do your own research. When you do, you'll never again believe the bullshit you've been taught. Till next time, this has been Jeranism and Debatism. Peace.
Thank you.
Nice.
Yeah. Yeah. It was nice just hanging out. Now go and hit the bell. Share it with the homies so that they could grow as well. They missing out. Jaren leaves no doubt. If you know what we bout, it's never for the cloud, don't fuck around. Hey, not for the clout, that's too cap, we calling them out. Balls get flat when you cover the route. Jeranism all in your mouth. Truth gets lost like all in the couch, but it's time to get up and make them get out. Uncover the route. Jeranism, we are the crown. Telecasting worldwide, check the globe is falsified. Space is spinning DFI, all just scientism lies. Telecasting worldwide, check the globe is falsified. Space is spinning DFI. All just scientism lies.
Who this be? What he about? You stay spinning, he said out. About flat earth, it's flat out. He's still standing when you pass out. Globers pound, scream and shout. He can turn you inside out. Yeah, surface deep, he's felt throughout. And he stay grounded, you spaced out.
We gotta run nowhere when we come fact check your facts and match your data. Concept is too abstract, what matters? Try to tune in, but the note get flatter. Tell me I'm flattered. Flatter than pancake batter, now we landed. Jeranism, I'm your captain. Speaking, telecasting worldwide. Check the globe is falsified. Space is spinning, DFI. All just scientism lies. Telecasting worldwide. Check the globe is falsified. Space is spinning, DFI. All just scientism lies. You know equations to the things you make the symbols for, but ain't really explaining what the symbols for. They try to teach you things against the things we taught before. No point in arguing now, they don't wanna talk no more. Okay, got a bite of the truth and now it's certain. That's what life look like when your mind is certain. Okay, got a bite of the truth and now it's certain. That's what life look like when your mind is certain. Thanks to the east side, thanks to the west side, thanks to the north side, way down to the south side. Thanks to the east side, thanks to the west side, big up to the north side, way down to the south side. Telecasting worldwide, check the globe is falsified. Space is spinning, DFI, all just scientism lies. Telecasting worldwide, check the globe is falsified. Space is spinning, DFI, all just scientism lies. Telecasting worldwide, check the globe is falsified. Space is spinning, DFI, all just scientism lies. Telecasting worldwide, check the globe is falsified. Space is spinning, DFI, all just scientism lies.